except when I tell you not to ask. And guess what? So I don't pick up all this stuff because that's not needed. Table below shows a set of values for x and y. Which equation best represents this set of data? We can look at to look for a slope, which should be our first step. We need to find that common difference. So we can't look at all of them because it doesn't always go by 1. But we have a few here from -2 to -1. That's increasing by 1, and y is changing by. We're going to skip this one. Or actually, we can look at that. This goes up by 2, and this goes up by, or down by 6. So we can kind of see if it went up by 1, what it would go down by. And then if we look from 3 to 4, that's +1 and -3. So we know our slope here would be would just be -3, which makes this problem fairly straightforward since only one of your answers has -3 as the slope. But let's practice because a lot of people forgot how to use point slope form. So in this case, we have the slope and we have 5 different points we can use. So if we look at our point slope form, which is y minus y1, 1 down here, equals m times x minus x1. Now we can pick any of these points up here. Which one would be a good one to use? We could use the first one. Could use the last one. The third one. I would use this one simply because it's got small numbers. So that means that x1 we would replace with a 1. y1 we would replace with -1. Everything else just gets brought down. So we have y minus -1. Oh, the slope, sorry, forgot about that. Our slope is -3. We can clean this up a little bit. Y minus -1 is y plus 1. We can distribute this out. So -3 times x is -3x. -3 times -1 is +3. And then to get this in a slope-intercept form, the very last step would be to do what? To get y by itself. So we have to -1 from either side. And we get y is -3x plus 2, which is answer C. Okay, so just a good way to check it, because even though obviously we knew that answer was C. All right, 1 down, 32 to go. Same thing, more or less. So this time, none of these go up by 1. So we can use another way of doing this. We can look at 2 of our points. So we can say, we can call this one x1, this one x2. We can call this one y1 and y2, couldn't we? Yes. And then do we have a formula that will tell us slope? We have change in y over change in x. So y goes from 1 to 3. X goes from 0 to -3. So what's 1 minus 3? -2. 0 minus -3 is +3. Remember, subtracting a negative is the same as adding a positive. You're adding. Because you're taking away 3 negatives, which really means you're adding 3 positives. So here's our slope, -2/3. And again, it's the only one. But what are we going to do? We're going to use point slope form because everyone's like, point what for? What? I don't remember doing that. We never did that. Mr. Ellis is a bad teacher. It must be true. Jerry agreed. What? Uh-huh. That's why I'm recording it. It's not for you guys. You already saw it. If you talk loud enough. Sure, Holly V. Alright, so we substitute in. Actually, we need to pick a point here. What would be an easy point to use? 0, 1. So we can replace x1 with 0. Because that was the x value we just chose. What can we replace y1 with? 1. What can we replace m with? Negative 2/3. Everything else we just copy down. Alright. So nothing to simplify over here. Y minus 1. If we distribute on this side, negative 2/3 times x is just negative 2/3 x. Anything times 0 is just 0. That goes away. So last thing we have to do, just add 1. Are you laughing at the thing you just said? Because nobody else was. And we do get a confirmed answer of negative 2/3 x plus 1. It's probably because I'm low on batteries. Okay, nobody asked. Alright, what is the slope-intercept form of a... Oh, I can't even read it. Line whose slope is negative 2 and y-intercept of 3. Okay, that's actually really easy. So we have an equation for slope-intercept form. And hopefully you remember this one. mx plus b. What does the m stand for? Slope. Does it tell us what the slope is? So we're going to replace m with... What does the b stand for? Does it tell us that? That's... What are y and x? They are perfectly happy being y and x.
That's what you meant?
Yeah.
I didn't get it.
You know, when you're happy with yourself, you don't want to change.
But there's always room for improvement.
Not for y and x. They're...
It's dead.
Yeah, because I'm low on batteries. Deal with it. So we do have an answer. C.
Got it.
Alright, number 4. This one's a little bit more work. It says, what is the slope of y-intercept? What you need to avoid doing is saying, well, the slope is 2 because it's in front of x, and 6 is the y-intercept because it's by itself. Why can't we say that? Because it's not in slope-intercept form. So until it's written exactly like that, we cannot find, I mean, we could see it, but you can't because you're small. So what we need to do is we need to take, we need to rearrange this. So remember, before we get rid of the times 3, we need to move what? We need to move 2x. How do we move positive 2x? We take it away. So this is going to cancel out. So we have 3y on one side, negative 2x plus 6 on the other side. Now we can divide by 3, which means we divide everything on this side by 3. So this is going to cancel out. We're going to get y We can't do anything with this. We're just going to leave it as 2/3 x. And then 6 divided by 3 is 2. Okay, yeah, I know. You tell me the same thing like every 2 minutes. So what is our slope here? Negative 2/3. What's our y-intercept? 2. So our answer is A. Not O, A. Alright, number 5. W hat is the slope-intercept form of a line containing the points 4, 4, and 2, negative 1. So, to get slope-intercept form, we need both slope and the intercept. So if we don't have slope, that should always be the first thing we find. So we do have 2 points, so we can find slope from that. So we need to label one of these x1, y1, one of them x2, y2. Doesn't matter which one's which, I just put the first point first because I can. So then we have our formula for slope that says, the change in y over the change in x. So y2 is negative 1, not comma, minus over 2 minus 4. So when we work that out, what do we get? Negative 5 over negative 2. Since they're both negative, the slope is actually going to be positive 5/2. Right? So now we know it's either going to be A or B. Okay. So now we just look how can we get in a slope-intercept form? Well, now we have a point and we have slope, so we can use point-slope form. You guys weren't even in this class in the 4th week of school. Not this specific one. Alright, so let's use 4, 4, since there's no negatives. And we can't make a mistake since they're the same number, so we can say y1 is going to be 4. x1 is also going to be 4. Our slope is 5/2. Everything else gets to stay the same. So y minus 4, x minus 4. Now we just simplify what we can. So 5/2 times x, still have 5/2 x. 5/2 times 4, or negative 4, yes. So we could multiply this straight out. 5 times 4 is 20, divided by 2 over 1. So 20 divided by 2 is 10. Great. And then our last step, we just add 4 to both sides. We don't plus 4, we add 4. Because we're sophisticated folk around here. Negative 10 plus 4. So what is our answer? B. Alright. Hopefully we have 100 so far. Hopefully you're not lying to me. Some people are like, maybe. It's like, can I still be perfect if I miss 3? They're right now. Alright, back up here. Slope of the line containing the points 2, 5, negative 4, negative 3. This is, I don't know, this should have probably came before the last one. So if you can do point slope, you can probably find just slope. So we just label them x1, y1, x2. And we just use our slope formula, which is always change in y over change in x. So we have -3 minus 5 over -4 minus 2. So what's that going to give us? -8 over -6. Can we simplify that?
Yes.
This would be 4 over 3. Since they were both negative, they cancel out, and we just get positive 4/3. Yes, Jerry. All right. Oh, man. Segment AB represents path of a sailboat that passed through the coordinates 2, 2, and 5, 3. What is the slope of the path? So they added a sailboat here, but really, is this any different from that question? No. So again, they try to give you the illusion of like real-world situations when in reality, it's saying, what's the slope of those 2 points? Okay? Although now when you play Battleship, you can totally figure out the slope of stuff. Battleship is completely a math game anyway.
Really? I know, I have a method. All I do is
Hold on. Alright. And the method is not just cheating. You're not allowed to move your ships. So, it always makes me laugh when people be like, I'm going to guess here. That's a miss. So I'm going to guess right here. That's sort of inefficient. And then Will says, you just guess every other square. That's also inefficient, though. You can win doing any method. But if you consider that the biggest ship is 5, right? So if you start out and just guess every 5th one, because even though you won't have as good a chance of finding the small ship, you can get through the entire board a lot quicker. Because if you only have to guess 2 on every row, how many guesses will it take you to get through 100? If it's 2 per row for 10 rows, that would be 20. But if you go every other square, it would take you.
But then you hit those small ships too.
But do you still have a chance in those first 20 to find the small ship?
Yes.
Ah.
Yes.
Especially if someone's like, I'm on to Will's strategy. He always starts at the top, so I'm just going to stick all my boats right down here. Then what do? You put them all in the middle. Thank you. Okay. So, now you know. Next time you're playing Battleship. Also, be wary of anyone who takes little pegs and puts them into their own board wherever you guess. You know why? Because they're checking to see where they can move their boats to. Because they cheat.
Oh, that's totally me.
Yeah. So assume anyone who's tracking where you go is definitely cheating and you should not play with that person. Okay. Yeah. So, okay, we were answering this question. I remember now. So x1, y1, not x2. x2, y2. This is number the one after the last one we just did. Alright, so we fill in our numbers. So y2 is 3 minus 2 over 5 over 2. And this is just 1/3. So the answer is B. So any questions you get just asking for slope, please don't miss those. Those are kind of easy. Okay. I'm getting sick of these slope-intercept questions. Alright. So, we've done this one before. Remember, for it to be in slope-intercept form, it's got to be x and the constant have to be on the right side, and y's got to be all by itself, and Brian's got to be looking up at the board, otherwise it's not correct. So we have 4x plus 3y is 12. So the first thing we need to do is what? We got to move the 4x to the other side. So that's going to give us 3y on the left and negative 4x plus 12 on the right. Then what?
Oh, you divide all of them by 3.
We divide everything by 3. And we get y is and we're done. Or either one. Okay, you should be either working or listening though. If you're just doing your own thing, your grades are going to be bad and it's going to make me look bad. Remember, please don't make me look bad because otherwise I can't be nice. What? Alright, here we go. Something we can actually solve. What is the solution of 6x plus 2 equals 2 times 2x plus 2? So we need to get x all by itself, so we start by distributing what we can. So 2 times 2x is 4x, 2 times 2 is, so we have 4x plus 4 on one side, 6x plus 2 on the other. From here, we just need to collect our like terms, so we can bring, why would we move the 4x to the left instead of 6? Because if we move the smaller number, it gets to stay positive. Very good. So we get 2x plus 2 equals 4. As an added bonus, since we do that, we get to move the constant to the other side, and that gets to stay positive as well. So we get 2x equals 2. And hopefully at this point we say, duh. The answer is obviously x equals 1. And we can check that up here. We can say, especially if you're taking a serious test that counted as a major grade. I don't know what we're doing back here. 6 times 1 plus 2 equals 2 times 1 plus 2. And we can just check to see if that works. So 6 times 1 plus 2 is 8. If we just work out the parentheses here, 2 times 1 plus 2 is 4 times 2 is? If that does not work, your answer is incorrect. So please do everyone a favor and check these. There's no reason to get that wrong. All right? After school. Tutoring today, every Wednesday. Literally every Wednesday. Along with every Monday. Yes. Every Monday or Wednesday you can find me after school. Alright. Same thing on the next one. We simplify what we can, so we can say 2 times 5x is 10x. On the right side, can we combine 2x plus 3x? That's kind of a bad color. Okay. Now we just combine our terms, so we can minus 5x. So we can get 5x on the left equals, and again, hopefully we can say, duh, this is 8. And again, you could check that. I'm not going to, but you could, because we got stuff to do. 2 rectangles are similar. Okay. Rectangle A has a width of 12 and a length of 5. If clearly this says rectangle. If rectangle B has a length 6 feet, what is its width? So Roger, how can we solve this? You can use proportions. So we can start off, we can draw this just because it never hurts to draw a picture. This says it's 12 by 15. Does it? Okay. So the width is 12, the length is 15. So this has a length of 60, which means 60 needs to go with which side? On the bottom. It's got to go with 15. And we're solving for what is this width? So we could call this tiny and big. You can call it whatever you want. And we can take one side from the tiny rectangle, 12, and that corresponds to, and that's equal to, and now there's all sorts of stuff we can do from there. We could cross multiply it straight away. Could we also simplify 15 over 60? What is that? It's 1/4. So we can say 12 over x is the same as 1. And that makes our cross multiplying a lot easier. So now 4 times 12 is 48, and we divide that by 1. So 48 divided by 1 is 48. What's another way we could have solved this? Without the proportion. We could use scale factor. If we have 15 and 60, can we figure out at what factor they're being changed by? By 4. So we can say this scale factor is 4, which means I can take 12 times 4 and get 48. Okay, good. What's the problem with that method? It always works, but it's not always a nice, easy number. So, yeah, proportions always work. Or you could also use your calculator. If you could have divided 60 by whatever number this was and gotten a scale factor and then multiplied it by 12. How do you use it? Use the plus, minus, multiply, and divide. It's got a lot of fancy functions on it, but don't forget it can still be used as a calculator. Like yesterday, we were letting the 8th graders use it to find square roots, and they're still back there looking at the square root table, and it's like, there's a button on the calculator, and it does square roots. It's like, what a surprise. You can do math on a calculator? Son of a gun.
Oh, there it is.
All right, now that you've all found the square root button. While hiking on a trail, George measured his shadow at 12 feet long. George is 5 feet tall. All right. At the same time, he measured the tree shadow 60 feet long. How tall is the tree? I don't know what you're measuring yourself against. Like the bookshelf is an accurate display of height. So, as ridiculous as this question sounds, this shows up all the time. And actually, it's kind of interesting, the fact that you can actually measure the height of a tree just by using your shadows. So we've got Holly.
Wait, so how does he measure himself if he's like walking and trying to measure himself at the same time?
How do you measure your shadow?
Yeah. You're gonna be moving.
Well, if you can see the shadow, I know the shadow's right past that tile, right?
Yeah.
So then I can just measure from here to the tile. And even though when I move, my shadow moved, but I know where it was.
Yeah.
So I just measure the point where it was when I saw it. It's like the philosophical question. If George is alone in the woods, how does he measure his shadow? So he's 5 feet and his shadow, sort of watery, is 12 feet. And then at the same time, the tree, which is pink, and Christmassy.
I speak for the trees.
All right, it has a shadow of 60. So, whatever.
So he started out as George and then he changed
So, how could we find the height of this tree? We could use proportion. So we can say Holly to okay. We can pick something we know about the guy. 12, and that corresponds to. And then we also have. Because you don't speak for the trees, clearly. So now there's any number of ways we can do this. You could simplify this and get 1/5. And then we can see that the height of the tree is 25 feet. Again, we could have looked at scale factor. How could we get from 12 to 60? Times 5. So 5 times 5 is 25. Another thing we can do, because we've seen this example so many times, how far is it from the top of Holly directly to the end of his shadow? It's 13 feet. Because that's a right triangle. And as you see it enough times, you'll be like 5, 12, 13. Just automatically. Okay. Alright. Hush. Children. Population of a town is 13,000, increasing by about 250 people per year. Okay. Shh. According to the equation below, how many years will it take for the population to be 15,500? So, a couple ways we could look at this. If this is the population we want, we could substitute that in for P. So we could say 15,500 equals 13,000 plus 250y. And then we could subtract 13,000 from either side. And that gives us 2,500 is equal to 250 times y. And then what? We divide by 250. And we get y is. So it'll take about 10 years. Okay. Another way we could do this, which is exactly the same as doing this math out, but if you just think of it in terms of answering the question, like if you say this is how many people they want, this is how many people they have. The question is how many more people do they need? And we get 2,500, when we'd still do the total by what we have. And then you say if you need 2,500 people and you're getting 250 a year, how many years would that take? Then you would divide. So the logical steps you would take follow the mathematical steps you would take. So as long as you're thinking, which hopefully you're doing, you should be able to get this. Great. So if the question, let's say this is a little bit different question. If we just said, what does the 250 represent in this problem? But just in one word, it's the, starts with an R. It's the rate. So anytime you have an equation like this, whatever is being multiplied by our variable is always the rate of change. So something to keep in mind. Great. All right, one more. An aircraft carrier made a trip to Guam and back. That's where my brother is. He's protecting our freedom. Not really. He sends all these Facebook pictures like, I bought a motorcycle. I got a tattoo. I'm hanging out on the beach. That's like, defending my freedom. Whatever. All right, anyways. Trip there took 3 hours, and the trip back took 4 hours. It averaged 3 kilometers per hour on the return trip. Find the average speed of the trip there. Yeah, me too. Okay, so this is going to take a couple steps. First of all, we got to figure out how far is it. So if it took 3 kilometers, or it was traveling 3 kilometers per hour, and it took them how long to get back? 4 hours. So how can we figure out the distance? We just multiply. So if we take 4 times 3, we get 12. So from our boat, there's our aircraft carrier. All right? And here's our island. It's got one tree. It's a palm tree. He's not there. Alright, and this distance here is 12 kilometers.
Yes.
Okay?
Go back.
No, just that's the distance. So now it took them 3 kilometers per hour to get back. So they went from here back to the boat starting place. They were going 3 kilometers per hour. But it only took them 3 hours to get there. So if it took them 3 hours to get here, how fast would they have been going? 4 kilometers per hour. So now we have they went 3 kilometers per hour for 4 hours. And then they went 4 kilometers per hour for 3 hours. So it says find the average speed of the trip there. Oh, it just says what was the average speed. Okay, we're done. So it's just 4. I thought it was going to make us find like the total average speed for the whole trip, which would have been more difficult. What? Okay.
Wait, Mr. Ellis,
Huh?
isn't the answer basically there because it just shows 4 hours and then kilometers?
Oh, you have to do something.
Yeah, you could have looked at it and says, well, if it's 4 hours and 3 kilometers, then to go 3 kilometers would have taken, yeah.
That's all I did.
So